Oh gosh. Well, I was already streaming, but I forgot to start recording. Okay, so YouTube people, I'm sorry. Okay, sorry. This is a shorter video because I forgot to push record. Temperature is kinetic energy of molecules. Pressure is force between particles. I will probably say subscribe later, but yeah, I'll pull my YouTuber voice. Okay. So temperature is the kinetic energy of molecules. Pressure is the force between particles. Okay. Yeah. So I'm just gonna leave it at that. Okay. Density. And remember that, so temperature is measured in kelvins or degrees C. Can I go to the bathroom, please? Quickly. Kelvins or degrees C. Pressure is measured in pascals.
Yeah,
It's the chameleon from Leprechaun. So pressure is measured in pascals. Sometimes it's measured in newtons per square centimeter. We don't really worry about that one. In America, we measure it in pounds per square inch, or we measure it in, this is so dumb, in inches of mercury. So there's a, you know what a barometer is, right? A barometer measures pressure. Back in the old days, they would use mercury in a tube that was open to the air, and how much the mercury was pushed down in the tube and then back up like a U. It was a U-shaped tube that was open on one end, and how much it was pushed up on the other end would be. Anyway, isn't that dumb?
It's so dumb.
Sometimes, I mean, it's slightly better. It's millimeters of mercury, but it's still not great. So we use pascals. Okay. Pascal was a chemist. Surprise, surprise. Okay. Density. Okay. So we need to talk about density. What is density? How packed together things are. How much stuff you have in a certain amount of space. Stuff. Yes. Stuff in place. Okay? It really is just the amount of stuff in a place. We measure this in grams per liter. Okay? So density is the amount of stuff in a place. Okay?
So kind of how closely packed together the molecules are?
Yes. How closely together the molecules are packed. That is a very good definition. Okay? Density is the amount of stuff in a certain amount of space. Okay? Molarity is very similar to density. Yes?
This is my guess for moles.
Uh-huh. Uh-huh.
How many molecules there are.
Yes. It is the amount of moles in a certain amount of, it's generally a solution, in a solution. Okay? So it's the number of moles in your solution, okay? And we measure that in mole per liter. Okay? So molarity is number of moles I really need to recalibrate this board. It's very frustrating. I try and guess as to like where things are going to be. I'm just gonna go for it. Number of moles per volume. Holy cow, it actually like kind of worked.
Yeah.
Kind of worked. Okay, number of moles per volume. It's generally as a solution. Okay, or at least a mixture. Remember that a solution is a mixture of something, generally in a liquid. Okay? All right. So now pressure and temperature are pretty straightforward. What we need to do now is we're going to do some practice problems of density. Okay? Some practice problems of density so that you have an understanding of how it works. Yeah, let's do density first, and then we'll do molarity. Okay? So we're going to use cubes as examples of density. So prepare yourself for a beautiful drawing, everyone. And an uncalibrated board. Yeah, this could be messy. I just realized that I'm going to need more space up top. Because I don't know how long it takes. Okay, square.
Actually, it's a cube.
That's pretty good, right?
All things considered.
All things considered, that's decent. I'm supposed to do like the little.
What's that? Wait, push ourselves. Wait, we're doing practice problems?
Yeah. Okay, so we've got our cube here. Okay, you can draw a cube if you want, you don't have to. Let's say that each side is 3 centimeters. 3 centimeters each side. Let's just assume there's a perfect cube. Remember, nothing that I draw is to scale. So this is not actually 3 centimeters. And let's say that it has a mass of 86 grams. So we put it on a scale. We measure its mass as 86 grams. We get our little ruler and measure each side as 3 centimeters. Remember that density is in grams per liter. Okay? So we need to figure out what the density of this cube is in grams per liter given this information. Okay? Are we ready to give it a shot? Just to let you know, if you do not have a calculator, go grab one from the front of the class. You will need it. Okay? So grams per liter. The grams part is easy. Also, if it's out of battery, let me know. I've noticed that a few of them are out of battery. Okay. The grams part is easy. Okay? So we have how many grams? How many grams do we have? 86, okay? So the top part of our unit is already figured out for us. We already know that it's 86. Okay? 86 grams.
Wait, what's the 86?
What?
What is that?
This mass. It's how heavy it is, how much stuff there is. Okay? So 86 grams. Now what we need to do is we need to figure out what the size, what the volume of this cube is. How do you determine volume given the length of a cube, length of the size of a cube? All right, geometry, it's coming back to you. Yeah, and length times height times width, which is, in this case, because it's a cube, it's 3 times 3 times 3, right? It's 3 cubed. Okay? 3 times 3 times 3, which happens to be 27. Right? 27 centimeters cubed. All right, so we have the volume. Is this the right unit? Is this the right unit? No, it is not. Centimeters cubed is not the same as liters. But I will tell you, because this is an actual system of measurement that makes sense, we can convert from cubic centimeters to liters by doing this. 1 cm cube is equal to 1 milliliter.
Impossible.
Okay, isn't that sweet? 1 centimeter cubed is equal to 1 milliliter. Can you imagine? I just want you to take a moment and try and imagine trying to convert between cubic inches and gallons. I just want you to have a moment and think to yourself, I think it's something like 82 cubic inches in a gallon or something like that. Yeah, it's really stupid. Okay? With this, because this has actually been thought out, cubic centimeters is equal to 1 milliliter. Okay? So that means that we have 27 what? 27, that's enough. Okay, 27 milliliters. So, but here's our issue. Okay? Is milliliters liters? No, but how do we convert between them? How many milliliters are in a liter? 1,000. Yes. Yes. It's fantastic, right? So 27 milliliters. Okay? So what we're going to do is we're going to take grams, so 86 grams, divided by 0.027. Because 0.027 liters. That gives us what? What does the answer show you?
3,185.
3,185 grams per liter. No, don't worry about the decimal. Grams per liter? Yep, gram slash L. G slash L, just like this. Gram slash L. Okay? Any questions on this?
What's the
How much of the grams do we have to know either the volume?
You need to know the size of the object. and the grams to determine density. We can calculate if given the density and given the grams, we could calculate the size. And given the size and the density, we could calculate the weight or the mass. Okay. Let's see here. Okay. Questions on this problem? Any questions at all on this problem? No? Okay. All right. Feel good about that? Let's do another problem, shall we? What?
What will it be?
What will it be? Well, we're going to talk about that.
No, but like this one is density. What's the next one?
We're going to do another density problem. Oh, that's illegal. Okay? We're going to do another density problem, but this time it's going to be a little bit more complex. Okay? Now, instead of an object, we have a room. We have a room. And we happen to know the size of that room and the weight of the air in that room. We are going to calculate the density of the air in that room. Right? Again, we're going to use a cubical room. Right? So prepare yourself for another beautiful drawing.
So drawing the cubes.
Okay? Each side of this room is 4 meters long. So it's 4 meters by 4 meters by 4 meters. Okay? 4 meters by 4 meters by 4 meters. Each side of the cubical room is 4 meters. And we happen to know that there are 2,800 kilograms of air in that room. 2,800 kilograms of air inside the room. Inside the box. Okay? So, remember that a cubic centimeter is equal to 1 milliliter. Okay? And remember that a kilogram is equal to 1,000 grams. And that 100 centimeters is equal to a meter. That looks like a 2. I'm not trying to. It's supposed to be an equal sign.
700.
100 centimeters in each meter. So we want our answer in what unit?
So times 1,000.
Grams per liter. This is where it gets complex, my friends. Okay? This is where it gets complex. And I'll tell you why. A cubic centimeter is equal to a milliliter. But a cubic meter is not equal to a liter. It's because of the cubed. If you take a cubic centimeter and you times it by 1,000 and you think that it gives you a liter, it doesn't. It actually gives you 1 million liters. because you're adding 9 zeros.
So we have to do 64.
No, you don't. But what we do need to do is we need to convert these units into things we know how to convert. Okay? We need to do that first. So, how many centimeters is each side of this room? 400. Okay? So let's do that. So each side of the room is 400 centimeters. So what are we going to do? 400 times 400 times 400, which gives us 64 million. Okay? So we have 64 million cubic centimeters. Million, that's terrible. That's it. Really, it looks so bad. 64 million cubic centimeters. Yeah. Okay. How many grams do we have? How many grams are in a kilogram? So just take 2800 and multiply it by what? 1,000, right?
28.
2,800,000. Okay? So 2.8 million grams. Grams. Okay? We know how to work with these units now. Right? They're just bigger numbers. And that's okay. Big numbers are okay. So we're going to take 2.8 million. We're going to divide that by what? 64 million centimeters cubed. Okay? 64, 1, 2, 3, 1, 2, 3. All right, 6 zeros. 64 followed by 6 zeros. We get 0.04375. That gives us grams per milliliter. Okay? Because remember, we're in centimeters cubed. So we need to do one more conversion.
Wouldn't it be 64?
It is 64 million milliliters, right? So remember that the centimeter cubed. Oh shoot! Well, that's not what I meant to do. I meant to just highlight it. Remember that centimeters cubed are equal to milliliters. Okay, so we get 0.04375 grams per milliliter, right? But we need to get grams per liter. So we multiply it by 1,000. Okay, that's the last. So it's, okay, I'm going to go to the next page, and I'm just going to write out what we have, okay? We had 28 million, or 2.8 million. 5 zeros, 1, 2, 3, 4, 5. Okay? And we divided that by 64 million. That gave us 0.0 0.04375. And that was grams per milliliter. But we want it in grams per liter, so we multiply it by 1,000, because remember, there's 1,000 milliliters in a liter. Okay? That gives us 43.75 grams per liter. That is our answer. Okay? Does that make sense? A lot of chemistry is just working with units. Finding which units you know how to work with. And this is why the SI system is so important. If you do not use the metric, or what we call the SI system, you are going to make your life very difficult. Okay, I wanted to use some X footage there, but you will make your life very difficult if you do not use the system, because how easy is it to just move some zeros? Right? You multiply by 1,000, you divide by 1,000, you multiply by 100, you divide by 100, that's it. Okay? Questions on that practice problem? No? It was a lot? Just remember, yeah, just remember that you know some things. Okay, you know that centimeters cubed are milliliters. You know that kilograms are 1,000 grams. You know that 100 centimeters are a meter. Those are very important for you to understand. Okay? All right. Now let's do. What? Okay. Let's do another problem of density. Okay? Well, we're going to change what we know. Okay? We're going to change what we're solving for. We are now going to have the numbers. We're going to know the density, and we know the size.
Can we make a cube again?
Sure. Okay, we've got our cube here.
Are we doing this for temperature and all the
Nope.
others?
Temperature you don't need to worry about. Pressure you don't need to worry about right now. Density is what we're working on right now. So if we have a cube, again we're using cubes, that is 6 centimeters on each side, and we know that the density is 420 grams per liter. Okay, so we are solving now. We have the density, we have the size of the cube.
Wait, what's the density?
This is the density. So remember that our formula is density equals what? Mass per volume. Okay? So we are now solving for mass. Relax. This is algebra. You can do this. Yeah. So we have the density. Oh, that's lower than I meant to be. We have the density. And we have the volume. Well, we have the size of the volume at least, okay? So what is the volume of our cube? Ready to go. Figure it out. What's the volume of the cube?
Let's go through 6.
216. Centimeters cubed. Okay? So now we have the volume. We can just, what we can do is right now, let's just convert that into liters. Okay, let's just convert this into liters really quick. How do we convert that into liters? Take it to milliliters, which is just 1 to 1. So that's just equal, right? 216 milliliters. And then how many milliliters are in a liter? 1,000. So what does that give us? Divide by 1,000. It's 0.216. Okay? Okay, 0.216 liters. Does this make sense? How does this, okay, where did I lose you? Centimeters cubed are equal to milliliters. They're equal, they're the same thing. Milliliters, you need 1,000 of them to make a liter. So if I need 1,000 things, and I only have 216 of those things, then I have 0.216 of that thing. Does that make sense? Okay. So we have density, which is 420. So 420 equal to m, which is what we are solving for, over 0.216. Okay? How do we solve for this? Come on, guys.
Wait, what is the M?
We're trying to solve for m. We're trying to solve for mass.
Multiplying.
It's algebra, right? It's algebra.
So we do the triangle thing.
Okay? It's just,
So 420 times 0.216.
yeah.
Don't burst your appendix. Oh, wait.
I don't have one.
90.72.
Okay, 90.72. So all we need to do, I'm going to move to the next page, and I'm going to write this out again. 420 equals mass over 0.216. So all you need to do is 420 multiplied by 0.216, and that gives you mass.
9.7.
So what is it? 90.712. Sorry, 72.
Mm.
90.72. What is our unit?
Mass.
So we're solving for mass. What?
M slash L?
No.
M?
No. Density equals mass over volume. What do we use to measure mass? Grams.
So it's
That was fun. Thank you, Hannah.
what's like the answer? Like, you know.
This is the answer.
No. Oh.
We were solving for mass given density and volume. but we just had to do a little bit of conversions of our things.
So it's like finding the missing piece, kind of, to
Yeah.
what we're doing.
Right, and that's always what you're doing in science and in math, is finding the missing piece.
But it's just reversed
Are we
what
done with
we're
this?
doing.
We're done with this one.
So
In your notes, if you don't have this already, I want you to write this very big and highlight it.
Yeah.
Density is equal to mass in grams over volume in liters. Isn't it interesting that this grams over liters happens to be the unit that we use for density? Whoa!
Almost like somebody thought about this before making it.
Okay? We use this. I know that this seems like a super simple equation. It's just one division. It's one division. Oh, I could write out a very fun equation. We could do Coulomb's law. We're talking about Coulomb's law. The attraction between charged particles, depending on their distance and the sign of their magnitude of charge.
So if space didn't have anything but two molecules of, let's say, hydrogen, they're like a whole light year apart, do you think they'll eventually come together?
That's a great question. If space only had two atoms of hydrogen, we could actually calculate that density, which would be insane. I don't even want to think about how many liters the universe has in terms of volume.
Well, that's you can't even know.
You can.
Well,
You can do that math. We can do that math. We can absolutely do that. That's all we would have to do is find out. So we could just figure out how many meters long how many meters long a light year is. We multiply that by the light year size of the universe, which is about 90 light years in every direction.
always
It's always expanding, but I mean, we can kind of fudge the numbers a bit, right? And then we could calculate the density of the entire universe if you want. Yes. Okay, we're not going to do that. We're not going to do that. However, we next time are going to do some calculations in molarity. Didn't we have fun? Class is already over. Didn't we have fun? Okay, so this is the power of science, my friends. We are able to take a couple of things that we know, and using a scientific formula, we can figure out something that we don't know. That's pretty cool.
I've had a question I've been wanting to ask you for a week, but I keep forgetting.
Okay.
Can we evolve that into plant?
That's going to end the recording. Bye, YouTube people. Like and subscribe. Like and subscribe, please. All right.